It gives me great pleasure to introduce to you all Anthony Chabatoni, uh, presenting on Run It Back Db2 for zOS, all new 2024 SWAT Tales. Uh, Anthony's part of the SWAT team, and he always gives a good talk. So sit back, pour yourself a cup of tea slash gin and tonic, wherever time it is, where you are, and enjoy. Over to you, Anthony.
All right, thanks, Marcus. And if anybody has a gin and tonic or a vodka tonic or a beer or a diet Coke, please give me a toast on your afternoon. It's in the morning for me. So the SWAT tales, what I try to do on this session, I try to change it up to keep the excitement and keep the material new. And so what I try to just go through the things that we experience on the SWAT team or in our social circle in the lab to try to bring back to you guys. So as Marcus so elegantly introduced myself, I am Anthony Shabatoni for the people that do not know me, that I'm now leading the SWAT team. And part of our role within the DB2 organization is to do 360 studies, do teach a master class, and be advocates to various customers and be part of the development life cycle as well as the support ecosystem. So again, we're trying to share as much information, interesting information with you as possible. So today's agenda is going to go across really two presentation time slots. I'm going to start off the first 20 some slides today, talk about continuous availability. And then the next two topics would be log-based local recovery, where I scaled back my normal presentation and try to hit on some important things there. Then corruption scope identification. And then the next session after a 30-minute break, we'll talk about cyber vault, safeguarded copies, and what's going on in that space. So kind of piece these together, back-to-back presentations. If you guys do have a question, I can't see Marcus, so if there's a question, someone raises their hand, go ahead and you can stop me, and I'll
Yeah,
answer as we go along.
if anyone's got a question, either stick it in the chat or click on reactions and then raise hand, and then I'll pick that up.
All right, thank you, Marcus. So continuous availability. So customers make a big investment in zOS parallel sysplex, DB2 data sharing, but still are not able to achieve continuous availability. So it's more of an executive route than a technical route, because again, you get executive or management say, I paid all this money, I bought the infrastructure, so I should automatically get continuous availability. And in reality, what we see, and the reason why we do continuous availability studies, and we look at it from the lab perspective and support, a lot of customers cannot achieve continuous availability or mask plant or unplanned outages, whether it's not redundancy is not set up, there's no there's single points of failure, or the fact that we are going to experience sometimes outages and we're going to talk about fast restart and fast recovery, and what do we do to get the system back. And so I know I'm speaking to the choir here. The zOS parallel sysplex data sharing is the gold standard in terms of availability. Back in the 90s, when the coupling facility kind of evolved from IMS to into DB2 and having the coupling facility there in place for this, we can really truly grow horizontally our systems, and it gives us the base infrastructure to work on, which is good, and that's the investment that we make along with multiple CECs and multiple sites and whatnot. But the key here is, just because you have an infrastructure, additional ingredients are required to achieve the highest level of continuous availability. So just by making a purchase and plug and play, it's not enough. We need more. So we have to achieve active inter-system read-write data sharing, to be able to spread data across the group buffer pools, across different LPARs and different CECs, different data centers, to be able to spread that out for the highest resiliency. And then we need to replicate cloned applications. We like to use the term towers. You want to have multiple towers of infrastructure. And I'll show you a picture in a Kix environment. But if you have multiple towers that are like towers, then you could take the next step. And once you achieve the towers, you can fine grain dynamically route traffic to the various components and have at least two towers supporting the infrastructure. And towers could be a tower within an LPAR, can be a tower within a CAC, towers within a data center. And then again, be able to route traffic across those towers appropriately. And the ultimate goal would be able to take one tower out, do maintenance and do whatever, and put it back. Or if you have a unplanned outage, be able to take that outage, and even though you're losing part of the tower or part of the infrastructure, but we mask that experience from the application. We'll talk later about a couple of facility structure duplexing, i.e. asynchronous lock one duplexing. And then another piece we'll talk, if we do have a failure, if we have a problem, how do we automate and efficiently restart DB2 and restart the system. And Marcus, I'll do a sound check. Do I sound okay across the phone?
Yeah, absolutely fine. Clear as a bell.
Thank you. I'm just in a hotel, so I don't know how the internet is working here. So thank you. So we're gonna if you take a look at this diagram, I'll just spend a couple minutes here to explain the diagram, and then this is going to be the base of the various components that we're going to talk through here. So if we look on the left-hand side versus the right-hand side, it could be, I'm referring to this as Hall 1 and Hall 2. It could be data center 1, data center 2. It could be a data center that is on campus or a data center that is some kilometers away. And within that data center, we're just going to use it, show one KEC on each data center and 2 LPARs. And within that environment, on Hall 1, you had a failure isolated external couple facility that would house the SCA, share communication area, and the lock structure, and then you have an internal on KEC 2. So if you look at it, 4-way data sharing, this is a good starter kit for continuous availability. So I'm going to walk through the scenarios of availability: a DB2 member failure, LPAR, a tech failure, and a data center failure. So in the case of a DB2 member failure, you lose DB2A with that red cross through the line and LPAR 1, and all other components remain active. And so the objective is, if you are spreading the workload across 4 DB2 members, you're losing 25%. But if you have redundancy in application towers, the other 3 members are accepting the workload, but we still have retained locks, potentially in-out threads that we have present. And so we want to restore that DB2 back to its normal state as quickly as possible. So what's interesting is, if you go through and talk to various customers that we've done studies with, I'm calling out some common problems. It's amazing to me in this day and age that there's no automation. Some customers do not have automation in place to restart a failed DB2 member. So if that occurs, that DB2 member goes down, you're holding retained locks, that even though we're spreading the workload across the environment, those retained locks are going to be unavailable and in-out threads. And if there's no automation in place, it requires a call out to the technical resource. And then, believe it or not, I've just in the middle of a study in the States now, doing the interview process last week. When DB2 fails, not only does the technician get called out, which could be 10 minutes, could be 5 minutes, or could be 45 minutes, but they can't restart DB2 until they get management approval. As crazy as it may sound. And that delay with retained locks, if it happens at the wrong time, could cause a system-wide outage. It depends on the pages that are being held of that member. And another common problem is limited number of restart attempts. They'll, whatever automation is in place, will attempt to start DB2 one time. And most of the time, 95%, if not more, of that first restart will be successful, which is good. But there's always times when it's not. There could be a timing issue. It could be a hung address space. It could be a lot of different things that Murphy will come knock on your door to explain. But sometimes it just doesn't work. And so that one immediate restart is they attempt to restart and that's it. And then you're back to the scenario where you're calling out the resources to take care of things. And again, the objective here is to get that DB2 member up as soon as possible, no manual intervention, and please, no management intervention to start a DB2 member. Just bring it up as soon as possible, which a lot of people on this phone probably have it in some place, but believe it or not, some people do not. And so best practices, I'll give you two options around this. You could use good faithful ARM automatic restart manager on zOS, and you could restart that failed DB2 member. In this case, you could go maximum 3 restart attempts, and you would give the minutes around it. So it gives you, in this case, 3 restarts, and ARM's ultimate goal is your friendly dog chasing a bone. It's going to restart DB2 as fast as it can without delays. So that's built into zOS. Another process for restarting a DB2 member in place is system automation. And that could be whatever your favorite system automation product of choice. I'm using IBM terminology here, but it could be any automation. Automation, if you have strong automation people resources, you could build additional knowledge and restart logic into restarting a DB2 member, where you could attempt to restart that member very quickly, just like ARM. And then if it fails, you could take additional action. And one would be put a timer delay in maybe 30 seconds in case there was a timing window. And unfortunately, there are times when we have a hung address space, i.e. IR11 for whatever reason, or a dist address space. And if those address spaces remain active, that member will not restart successfully. You could build logic in there to go chasing the hung address spaces and cancel them. Because if you get called, whether it's Marcus or myself, I see Julie on here, any of us get called, our action is going to go out. Why didn't DB2 restart? It's a hung address space. You're going to cancel it. So why not automate it? So ARM out of the box, very straightforward. Any automation gives you a little bit of ability to do additional logic around it. Another piece of restart failure is exploit middleware recovery boost on a Z16. So if you have a Z16 processor, you have the ability to have a stage 3 middleware recovery boost. So what I chalked up on the bottom there on the left-hand corner with that red star is just that. If a DB2 member fails, or middleware fails, you have the ability to invoke the recovery boost, which will bring 2 zip processes online as full capacity engines to perform, to act on your behalf for a period of time. In the middleware boost, it's 5-minute intervals, and you're limited to 6 boosts per day. So if you have a Z16, then it's a no-brainer to set this up, and you have the recovery boost. And how do you set it up? Is you look on the right hand corner, on the right hand side where I've highlighted down below in yellow. You could take your DB2 master address space and do recovery boost of yes. So if that member fails, when he comes up, he'll invoke that recovery boost. So as long as you have it in your Z16, that's a good process. And I have not been privy to anything that would make that a negative experience. It's all good. It's like Christmas presents and birthday presents at once. Then the next piece is no automation in place to immediately stop CICS AOR traffic from a failed DB2 member. So if you remember when I talked about the towers, and this is a tower with kicks. In this tower with kicks, you can see you have the TOR, AOR, multiple DB2 members, multiple AOR members across the board. So in theory, you lose one of these towers and CPSM and kicks will route, or if you have something else in place to route traffic to the existing AORs attached to a surviving DB2 member. So the challenge here is with WLM, there's a phenomena that's called a storm drain effect. So there's two things about the storm drain effect. One, unless you take additional actions, CPSM will still route traffic to an AOR that has a failed DB2 member. So again, out of the box without taking additional action, that will occur. And what compounds the issue is that when CPSM calls upon WLM to see where to route traffic, he's going to look out there and he's going to say, oh, the traffic that's going to the AOR that has a failed DB2 member, it's the fastest transaction known to man. And not only am I going to route traffic there, I'm going to route more traffic there. So tsunami. So it actually compounds and makes the outage, makes the failed transactions even worse. So storm drain effect with that. So the good thing is there are solutions around that, and there's really two of them. If you're selfishly in a DB2 member only an environment with DB2 transactions and no VCM, no IMS or anything in kicks, one thing you could do is develop a hammer approach in method one, develop automation, see that the kicks and DB2 members are detached, and just stop all the workload from going into that AOR and CPSM by issuing these close commands that are out there. And this will force all the traffic elsewhere. Now, if you are a DB2 only shop, this is perfecto. It will work just fine. If you're a VCM or there's other workload coming in and you're shutting things down that's not dependent on DB2, those actions will be shut down also. The other method that we came through from a kicks and DB2 perspective is be able to set CPSM up appropriately. And because we experienced this problem and the propaganda of us sharing this, we developed these two parameters in CPSM, which is called append crit and append thresh. And what this does is when we detect a negative 923, a failed connection, we mark that AOR 100% unhealthy. So it's 100% unhealthy, and we don't route any transactions there. So this will give DB2 the chance to restart in the background, hopefully in minutes. And then there's a timer pop that will trigger through and will continuously mark those environments from 100% unhealthy to 95% unhealthy down to whatever threshold we set for a bend crit. We'll say 30%. And then CPSM will send a sacrificial transaction to that AOR. Is it successful? yes. And then we then route 50% of the transactions there until we hit the second threshold, something lower than 30%, if in my example. And we hit that threshold and we're still haven't experienced any negative 923s, then we're back to normal. If anytime in this event crit and event threshold that we get a negative 923, we again start marking that AOR 100% unhealthy again. So the goal would be to try to time these parameters up with your restart DB2 in the background. And so the last piece of DB2 member failure, and then I'll take a break to see if anyone has any questions, is DDF, to mask planned outages from DDF. So a lot of customers do not have present Sysplex WLB. They're using Sysplex distributor, and when a DB2 member goes away, that connection from the server is still somewhat there, and the application server will use its pool and try to route transactions to a stale or a connection is no longer there, and there's no retry logic, which results in a failed transaction. And this is both from a planned, unplanned scenario. So the recommendation, and we've been saying this, and I just did a webcast approximately a couple of 2 or 3 months ago on DDF, is you want to look at exploiting, enabling Sysplex WLB, Sysplex workload balancing on the driver. And what this does, it gives us the ability, if you look at the picture on the right-hand side, it gives us the ability to, in an IBM data server driver picture, to separate the logical connections to the transport. The transports are going to be connections to the mainframe. The logical connections are threads that will be attached to a JVM or a .NET thread application pool threads. So we get logical connections, and then we can route to a transport. And if that transport is unavailable to a failed DB2 member, we automatically reroute to the surviving transport. So any mass or any problems or any unplanned or planned outages on connections or unavailability is masked from the application, as long as obviously one DB2 member is up. And so that would be the recommendation. So if you have all these components in place from redundancy perspective, multiple DB2s, if you lose a DB2 member, the goal is to route it elsewhere, and then any retained locks that are held or any in-doubt threads to be able to resolve them as quickly as possible for any of the other residuals. So I went through a lot there. I'll just give a quick breath if anyone has any questions in the chat. If not, I'll move on.
No questions yet. And if everybody's like me, we're just listening with rapt attention. Carry on.
I didn't put anyone to sleep, or someone didn't start their 100% happy hour, I hope. So now we're going to look at the LPAR and KEK failure. The same picture that we had before. This time, either you lose one LPAR of 4, and you have 3 surviving LPARs, or you lose a KEK and you lose 50% of the workload. And so now we don't have to worry from a DB2 member restart in place parameter. It's unavailable because that LPAR and a KEK is unavailable. So we have a process in DB2 that's been out there for years, is DB2 restart light for DB2 cross system restart. And a lot of people, not all, confuse this. In restart light, there's 3 flavors: restart light yes, restart light no in doubts, and restart light cast outs. And the 3 of them, the quick difference behind them, I'll go in the next slide. Restart light and no in doubts, they're going to come up and they'll hold some high level retain locks. There's a slight difference between no in doubts and yes, and yes, it's around in no in doubts. We'll talk about that. Cast out is we spend a little bit more time on that cast out on the restart, and we flush the group buffer pools for get rid of all the retain locks. And again, it's only for a cross system restart is the design point to bring DB2 up in a light mode, a small footprint, because a lot of times that surviving infrastructure is not designed for double the memory, double the storage to handle the workload. So this gives the ability to, if you build out a 2x2 or build out resiliency in our picture, you have other people to accept the workload, and we just got to get rid. We got to release, resolve these in-doubt threads, and retain locks as fast as possible. And during this restart light process, we don't allow new workload to come in during that restart, and it could shut down as Ken, and I stress Ken, I'll explain why, shut down the DB2 member automatically after it goes through restart light. Now, and I put this in bold, restart light can be much lower than a DB2 normal restart, and I'll talk about it on the next slide. And the other caveat that I put down here is, in the two of them, restart light is not necessarily intended to restart in place on the home LPAR, because if you don't have the storm drain effect, if you restart that DB2 member in a home LPAR, let's say you go back to the original scenario, when we start and come back up and come down, then we're back in a scenario where the AOR is attached to a failed DB2 member. So in that case, you have the memory available and the footprint, start it normally. And the other scenario is restart light is not intended to be used in a disaster recovery restart, group restart. That's been can it work? Potentially, but I've known there's been issues around the forward and back recovery. So in a disaster recovery, if you want to try to escape a shrunking down infrastructure, please don't go down the route of restart light. Restart light and postpone aborts. So we have in DB2 the ability on a restart for postpone aborts. So if a unit of work crosses over, it's going to take too long to back out, then we could start DB2 up, and those units of work will happen in the background. And so everybody else is successful except for that misbehaving transaction with long rollback. And when you're doing restart light, and you have L backout of just auto, then during that process, we change it, is ignored, and that is treated as L backout no. What that means to you is if you have one bad transaction rolling back in a restart light scenario with L backout equal auto, your subsystem's not going to come up and finish restart until that long running unit of work is fully rolled back, which is not good. So if you haven't already done this, take a look at your ZPARMs, and you want L backout light auto, and that gives you the ability to have the behavior of auto and plus auto in a restart light scenario. So it's the same as auto, but it reserves the ability to do that into restart light mode. Restart light and in-dot units of work. With light yes or light cast outs, when DB2 goes through the restart light scenario, if there's any in-dot units of work, two-phase commits that are not resolved, that DB2 member will not complete restart light until that in-dot unit of work is terminated or committed. Restart light yes is the default. So if you ever have that scenario, you're exposed to this condition. So what are the options? The options are, if you have mentioned that on a failed LPAR or a failed CAC, if you have the real memory in the surviving infrastructures, you could bring together DB2 IMS, DB2 kicks together as a full footprint. Start them normal. DB2 goes through normal restart. Kicks and DB2 will connect, resolve the in-doubt thread, and then you could create additional automation to stop that infrastructure. So it's all memory dependent on the surviving infrastructure. Option 2 is to use light no-in doubts. And so what would happen, again, for speed and availability, is if you use this option, if you have any in-doubt threads, DB2 will go through restart light, and we're going to forget about these in-doubt threads for now and come down. So the goal would be to come up and down as quickly as possible. We don't want any manual intervention for the in-doubt threads. Hopefully there's not many of them, and then we could then take additional action of bringing the system back to resolve the in-doubt threads. But we get the majority of the system back up and running. And this is the option that we preferred if you have RSAF, KICS, IMS, two-phase units of work. Now, with restart light and retain locks, with yes and no in doubts, some will clean up most of the retain locks. And I say most of them, but there's going to be some high-level locks still held, retain locks. And you should see this message at the end of restart, this DSM T804I. And you're going to see retain locks at X mode page stacks are released from the application perspective. But you're going to get this message, and don't freak. There are modified locks owned by this DB2 member that haven't been, they're still being retained. And if you're holding these, for the most part, normal application activity will resume. What is limited is DML process for like a mass delete, any drainers, online reorg, or anything that would do a drain. And hopefully during the outage, the online reorgs are not running, they're become not as important. But again, the application page locks will be available. It's just these high level locks. And they'll be cleared up during a normal restart when you bring things back, the LPAR or the CAC. Now, I did a therapy session probably about 9 months ago for a large brokerage firm in the United States that they were freaking that they lost a CAC and they had all these retained locks, and they were worried that there was a high level, they had quite a busy system. And that's just a therapy session. Just relax with those. As long as you're not doing mass application deletes or online reorgs, you should be perfectly fine. And then when you fix the hardware problem, when you bring things up, they'll be released. So don't let the big number freak you out. And again, that when they did bring everything back, everything was fine, and they didn't have any mass application deletes or any online reorgs running. So that was a good thing. Another big piece of this is one of the things that we talk through. If you lose a KEC or LPAR, you're gonna need most of the time additional resources, CPU, to handle the workload on a surviving KEC. And if it's a reactionary basis based on exceptions monitoring, alerting, and calling, and a manual decision to add additional capacity, and takes executive approval because I'm going to spend money to add an engine for capacity on demand. And it's normally a binary decision. By making that waiting a manual decision and a conference call, you must not only accept the risk of not adding the engine, but the consequences. So if you lose at the wrong period of time, 1 of 4 KECs or 2 of 4 LPARs, you had CPU peg in that scenario. Until you add the additional CPU, you could have failed transactions, you could have slow transactions, you'll have more threads in the system that will elongate it and potentially cause parlay avalanche into a full system outage. So if I always ask this question, if you are running hot and you lose at the wrong period of time and you have certain criteria, if it's always a binary decision, add one or two engines, why go through the process of a phone call, a management discussion, justification? Why not do that up front? And this, I call it a self-healing process. We've seen a couple customers here in the last 12 or 18 months that have listened to our propaganda and they've implemented this. And basically they have criteria. If their CPU is at 87%, or if their queue depth at whatever, at a certain number, they will add additional capacity. It's pre-approved by management, and they are doing it so that that initial flow of a DB2 crash or an LPAR crash doesn't cause an outage. And so it's worked pretty well. It's an evolution. Your first time that you do a quote self-healing process may not be perfecto, but you're going to grow with this, and you get everything in place up front, and then add it when you hit these thresholds. And the two customers in the last 12 months that we've done studies on, they've had tremendous success by going through and adding this process. And then the last piece of this is no automated process to immediately IPL a failed LPAR. And you're saying, Shabatoni, why you tell me I have 3 members available out there? What's the rush behind this? It's because of the in-doubt threads that you want to bring those back, and you do want to bring back your normal, your whole infrastructure. So if I talk through an IPL process, not the IPL process, if you're the fastest IPLer in the world, it's relatively fast. But the decision process around that can be 30, 45, 60 minutes. And you'll have those in-doubt threads unavailable. And it's a manual process to go out and collect the diagnostic information, talk to management. What do I need to give IBM? And then I need to IPL, and some people say, well, do I have a contingency LPAR? Do I IPL in place? So there's always a discussion around that. And when do I do it? Do we get all the data for IBM? And then perform the automated IPL process. And almost everybody has, once you initiate it's an automated process. And typically in this scenario, because it's a reactionary basis, it's approximately an hour. It could be slightly shorter or extensively longer, depending on the company. So why not automatically IPL this scenario? Again, most of the time, if you can IPL, you're going to IPL in place. So there's 2 flavors of this. One, non-GDPS. There is a parameter that's out there in Farmline. They could go out there and you could use the auto IPL option. And you could say, I want to do, in this case, a standalone dump, and you could put the volumes around that. And you could then put your last image, MBS image, to IPL to. So again, just like DB2, just like engines, it's normally we're going to IPL in place. If we can't, we mark it, you can't do it. But as long as it's in a process, in a state that you can, why not let auto IPL in place to do this for you? And again, it's amazing. It's been out there for a while. A lot of customers are looking through it. I'd say a small subset of customers are using auto IPL. I think that should be the default. And then GDPS auto IPL, if you have GDPS in place, you could also have the GDPS do the auto IPL. And then the one thing we don't do today that Dave Peterson and team are looking at getting feedback is GDPS doesn't perform a standalone dump. So today you'd have to build some additional automation around that to do it. And we're looking at getting feedback from customers to see if it makes sense to add the resources to add it to GDPS. The other problem we have single points of failure for AOR regions or CICS, could be legacy, And some of these legacies could be quite important. And those transactions, if you don't take in additional action until this IPL completes, they'll be unavailable. So that's another reason to get an IPL quickly as you can. And if that LPAR is going to be down and you can't handle the business disruption, then it's a manual process to start kicks that standalone environment someplace else. Again, during that time frame, those transactions are unavailable. So the recommendation here is if you had a failed LPAR, failed KEC, and these transactions, if you had standalones, legacy that are very important, build automation to start it up on a surviving LPAR temporarily and bring it back when you re-IPL. So that covers the LPAR and KEC failure. Marcus, if there's no questions in the chat, I'll go forward, but if there's any questions, let me know.
No, go ahead.
Okay. So now let's look at a data center failure. So what we've been hearing here for a while, the objective is to achieve continuous availability during an unplanned data center outage. So if you look at this environment, it looks nice, right? You have 2 data centers, you have a KEC, you have 4 LPARs, and you have an external coupling facility. So now the question is, will this infrastructure give me continuous availability over a data center failure? And if I was in a room, I would make sure that everyone stood up and raised your hand. But for time and being remote, I'll just go through the scenarios. So if you lost Hall 2, now I lost 2 Db2 members and I lost the primary group buffer pools, which are duplexed. If I lose Hall 2, we'll achieve continuous availability. So we're good in that scenario. Now, if we lose Hall 1, so now we have failure isolation with the external coupling facility within a data center if you lost an LPAR or a KEC. But if you lose the whole data center, that means you lost 1 Db2 member and you lost the lock structure in SCA. Db2 is going to crash because to rebuild the lock structure, you need all the Db2 members available. So you lose Hall 1, you have double failure, Db2 in the lock structure, and now you're going to go through group restart. So even though that we think that we have external coupling facility and continuous availability, we do not. And so unless you have a third isolated data center with an external coupling facility out Hall 3, which a lot of people, and I wouldn't do it myself, but you're not paying the cost of a third data center, you have 2 options, and that is synchronous or asynchronous duplexing. And so I'll walk you through the synchronous lock duplexing because of the volume, and then I'll walk through the asynchronous. So to show the problem here is I have the halls are cross distance. So in the synchronous lock 1 duplexing, I have a transaction comes in, he puts the request out to the lock 1 primary and lock 1 secondary, and we do some communication between the primary and the secondary, and only after we get that communication, it could be across distance, we send the response back. And we're only as fast as the slowest response, which obviously we're going to probably go async. So instead of going 3 to 5 microseconds locally, we're at 30 microseconds for the remote, and that's your lowest common denominator. Is your slowest element that will delay that process and make it longer. Then after both responses come in, then we return the lock request back to the requesting application. So people that implement this for ultra availability, they paid the CPU price and response time price for this. Now in Db2 version 12, we came out with asynchronous CF lock duplexing. And so this basically, we knew customers wanted to duplex the lock structure, and we want, because of the high volume, and do it efficiently as we can. And we came out with it in version 12. It increases the likelihood of being able to duplex, and even with the distance. So the difference here is, and hopefully this is very visible to you. The request comes in from the app calling application, goes through Db2, IRLM, XCF. It goes to the primary lock structure, is sent out. And the primary lock structure then will return the lock back to the calling application. So we're looking at 3.5, 4 mics in a highly tuned environment. And then afterwards, we have some signaling going back to the primary to secondary. We're going to share what we call last committed sequence number. And we go put that back. We send it from the primary to the secondary, and the secondary sends back to the primary where he's at. And then we order the sequence of these writes to keep these two lock structures in sync. And occasionally we'll do a query back and forth to XCF. And what has been good with this is most of the time the requests coming through on the lock request, the lock one on the secondary is lock request -1, is a majority of the time, and that's what the primary knows about and what the XCS knows about it. So most of the time we're up to speed in sync, and the request is be able to be granted without spending the additional time. So it's really been the responses here that we have customers that are rolling this out, and some may be on this call. The experience has been a very positive experience with asynchronous lock duplexing. It's not free. I'm just going to explode this out for time. It's not free. There's going to be a little bit extra time on the request. So if I mentioned 3.5 mics or 3 or 4 mics, we normally add about a mic to that request. There's going to be additional CF CPU, so you'll have to take that into consideration, and you have to have couple facility connectivity. And you can see the numbers here on the utilization that it's going to cost. We worked through this with Dave Sermon, and so when I get done and make this a PDF, you'll see that the formula there of what the cost will be. But it's been a great, so far, been a very good experience with customers going that way. Gives you the ability to have continuous availability over a data center failure, and also gives the ability of potentially retiring external couple of facilities and go with the internal only model and still have the availability. So that covers the high continuous availability topic, both from a local perspective, a Db2 member, a KEC failure, LPAR failure, data center failure, asynchronous lock duplexing. So in the last 9 minutes of our time on this session, before we get into Cyber Revolt, the next one, let's go into the scenario from continuous availability to a recovery scenario. Now, we teach in IDOG, we have a workshop coming up in North America, and I'm sure that same workshop will be in EMEA. We teach this during the master class, but I'm going to scale down on the things that are important with this. So the recovery assets, just want to put things in context. We're talking about Db2 active logs, Db2 archive logs, and Db2 image copies. So I'm going to talk through the common risks and common problems and risks. So wrapping around the Db2 active log pairs too frequently. So it depends on your log size. We keep track of, you can keep track of how quickly you go. You have 50 active logs, how quickly you go from 1 to 50 and wrap around. And the challenge is if you wrap around the active logs and you fill them up, then what does Db2 do? He stalls. So we want to make sure that doesn't occur. And so if you have, the rule of thumb is approximately 6 hours of log data in active log data set. That gives you the ability to handle surges, unexpected things that are go on, and then also if there is a problem, a VTS problem or additional information. The second piece of this is if you have archive logs, you're going through them very quickly and using VTS to replicate. We have customers that have gone through wrapping around the logs in 5 minutes, and they have during the batch process VTS replication to the secondary data center 10 minutes. So if you had to do a disaster recovery, you have the active logs that are synchronously being mirrored, but you only have a gap between 6 minutes and 10 minutes. And then not proactively monitoring things. Writing, another common risk is writing archive logs and Db2 image copies to tape or VTS. That technology is very good, but remember, even though VTS is backed normally by DASD 100%, it is a tape unit to the operating system. So if you have the archive logs and image copies that are potentially stacked or archive logs on tape, if you're doing a recovery process, it's going to be serialized. Only one person could access it. Then if you are writing your archive logs and DB2 image copies to DASD, organizations forget about monitoring the growth or do it too late. So if you fill the pool up, image copies fail, or in the case of archive logs, archive logging could fail and run through the active log. And the last piece here is naming standards. Some people still use don't take advantage of the ZPARM parameter archive logs to put a date and timestamp. And also customers are using GDG base for the image copies, which is not a meaningful name and adds some risk. And then only a single image copy is created through a log no event, online reorg, or a load resume log no. So if by chance there is that Murphy knocking on your door and there was a problem and the one image copy was corrupt, you would not be able to recover through a log no event. And even though it doesn't happen very often, we wouldn't have it on a slide if it didn't occur. So the recommendations for the active logs is you want to keep at the minimum of 6 hours worth of logs for the active log data sets. 24 is preferable, but 26 is the minimum, so you have the ability to react. And in version 12, you could have up to 768 gigabytes per log, which is quite large. Normally feasible is about 30 or 40 gig is a good number. And you have 93 active log pairs. So you can use those combinations to size your logs accordingly. Previously, before version 13, if you're using all your 93 log pairs and they were too small and you wanted to resize it, you had to stop Db2 to remove an active log from the bootstrap. In version 13, we give you the ability to do an online delete of an active log as long as it fits a certain criteria of not being touched. So we could delete and re-add it. Normally, it's been out there for a while. It does support resizing, encryption support if you have to recreate the data sets.
Before anybody else jumps in, I've got a question. Did you say 30 gigabyte per log is a good size?
What we've seen, Marcus, is the higher end. Some customers here in South America, they're about 40 gig. And the reason why 40 gig is so far kind of the number is the fact that if you need to archive, it takes a longer time to archive. So if you had a DB2 bounce or something, it takes a little bit longer. So feasibly, it's about 40 gigabyte today, and that hopefully that may change if you ask me next week or next month. But right now, about 30 or 40 gig, Marcus.
Okay, cool. Thanks.
And that's just from one customer. They're really stretching that. Archive logs, write both archive logs to DASD, keep archive log one, active log, archive log one data set on DASD for 24 hours to 48. Archive log two could be migrated immediately to save DASD. Take dual inline image copies, make that commitment so you don't have that an issue just in case. And this one here, at any sign of data corruption, implement a procedure to keep the assets from rolling off. And it's not that you're going to recover back 15, 20, 30 days from now, but it's going to help us for diagnosis of a problem if we have to go back and look at the active logs, archive logs, and image copies to look at a problem or advanced recovery with a redo SQL, your favorite log tool. Couple quick bullet items there. Set zparm timestamps that yes, the timestamp will be part of the archive logs. And then with your image copy naming standards, try to put a day and type to make it meaningful. And then lastly, through the life cycle of your how long you're keeping your recovery assets, create a health check job to not only to look at least the one full image copy, but two, so you have a backup plan. So N and N minus one, and two for a log no event, and flag it when it's not the case. So Marcus, I think I am done at the end of my time, but I'm going to just touch, if I could just have 3 minutes, I'll just touch high level from a, a, a mass application recovery perspective.
Okay, sure.
And in a DB2 mass application recovery, it does happen. And it's, there could be various different reasons behind it. Plan B for disaster recovery, logical corruption. We'll talk cyber attack, code bug, microcode failure from DASD or the coupling facility. Scope could be one object, could be half the objects, could be all the objects. And DB2 log-based, this is my favorite quote of all time. Log-based recovery of multiple objects is rare. We get 2 or 3 a year that we have to fight through. But statistically, it's more frequent than a true DR event. So we test DR, but we never really test. Well, a lot of customers don't test mass application recovery. So it's a whole scenario of the traditional data backup strategy is that we developed 30 years ago, doesn't support a RTO, a fast RTO, RPO. There's a various different reasons behind that. And the goal would be to develop a plan, design, stress test this, optimize it, and repeat, and to have that scenario. So if you're one of the 2 or 3 customers a year, and I come to your door, Hawken comes to your door, and we're smiling or a frown on our face, we could fight through this together. And a lot of the pieces here is there's no design, no optimization. We're not going to spend the resources behind it because it's never going to happen to me, but it does. And we talked about the VTS piece of it. So when you're in a scenario, it's really, I'm thrown into the equation and I'm sink or swim, and I have to create jobs, sometimes catalog direct recovery jobs. And so going back to recovery assets, we would like to keep archive log DASD, keep recovery assets at least 24 hours on DASD, and that could be a combination of active archive logs. We said 48 hours would be the best here. So 24 hours of active logs and 24 hours of archive logs, or on the right-hand side, have that 6 hours of active log wraparound time and the remaining in the archive log on DASD. And if you're using DASD, just optimize your block size and zparms. And so, let me just make this big. So the key is to be proactive. What table space can I recover first to bring my system back? Maybe I could recover 5 or 6 objects and then come back and recover the rest in the background. That's one thing you do. In a lot of cases, it's recover all or nothing before I get the application back. We don't think about other non-DB2 data, VCM, IMS, or as we know, some people are replicating data off-site. So those are things to think through. You want to bring back the critical applications and the corresponding related data. And then the big piece here is when you are developing your image copy process, don't build it because I want to get necessarily the image copies done quickly, which is always nice, but design your backup process to support a fast RTO if you had to recover these objects back. And again, one size doesn't fit all. You could look at flash copy, you could look at backup recovery indexes. There's a whole bunch of laundry list of things you could look through. And then if you're writing to tape, you might want, if you have mass application recovery or stacked data sets, you want to get that to DASI to get parallelism. And for a flash copy, if you're utilizing it and then migrating off the HSM, you have to recall it before you could, on the flash copy perspective, before you could use it. And my very last slide, and I'll be 5 minutes late, so I apologize, is data integrity checking. So a lot of customers don't have the ability that the first signs of logical corruption, the 00 Charlie 90101, there's no ability to non-disruptively check to see what the scope of that corruption is. And so the check utility is one critical piece of that, but to do it non-disruptively, you need to have flash copy enabled to be able to flash off the copy data sets and perform the check utility over there on those. If you don't have flash copy specified and you see in red that I have check for fast replication preferred, if Marcus were to go out and do a shear level change check index job and flash copy wasn't there and it's preferred, we'll allow Marcus to do that. But we're going to cause an outage because during that copy process of the table space index, we're going to put the source object in read-only status. So in this case, you want to check fast replication from preferred to required. And if flash copy is not enabled and you have a DR environment, another form of looking at this, I bring up my DR environment. I can run the check utility. I don't need flash copy because you're running on a copy version with not impacting production. And the goal is identify the scope and then develop a recovery strategy based on the scope. 2 objects, 50 objects, 1,000 objects will then dictate your recovery strategy. So I apologize for being 6 minutes over. Please take a snapshot of the QR code and supply the feedback. I do want to make sure I'm delivering what you want to hear. So your feedback is important to me. And if you give me a good feedback, Marcus will invite me back. And again, if there's any questions on here, you could feel free to send me an email or ask me whenever you would like.
Thank you very much, Anthony. You've brought many memories back, flooding back. I haven't been a DBA for more than 5 years, but it's like I left the job yesterday. Thank you very much. It was a very interesting session. Once again, everyone, please fill in your feedback forms. Just click on the link on the agenda. And we'll see you again tomorrow. Thanks very much, Anthony, and thanks everyone. Bye for now.
Thank you.